Okay, so let's take a look at it. It says, which interval of theta corresponds to the shaded region in the figure? And the figure is of the figure of f of theta equals r, 3 minus theta. Find the area of the region. And it says figure 15 on page 140. Let's take a look at it. This is figure 15 on page 140. I realize there's some issues over here, and I want to point out what some of the issues are. And I would certainly, if I were a student in a classroom, I'd be raising my hand now saying, could you clarify? Well, what I'm going to do is, I'm looking at this thing over here, and I start to realize that I'm really not sure if this section's being included. So I'd have to ask the teacher that. And the teacher might say, gee, let me think about that for a second. And what I'm pointing out is that looking at it, I see the shaded region. My question is, it looks like it's doing something like this over here. Now, I want to say if I did that, my rotation there would be, I'm at pi over 2. And if I came over here, it comes to the origin. This occurs right here when theta is equal to 3. But I want to claim over here, what happens over here, once I surpass the 3, right, I'm not at pi yet, you're going to start getting negative values for r, which means it's going to go below this thing over here. It's going to go below. Now, I'm exaggerating it there, right? I'm exaggerating it there. And then when it hits pi, this one hits pi, by the way. Someone says, well, how do you know that? Pi's over here. But what happens to it, you would get r equals 3 minus pi. And 3 minus pi would be, like it's a small number, something like this over here, right? And there'd be something below the curve there. Now, again, I'd have to ask the teacher that, is this picture indicating that we should be stopping at 3 or at pi? All right? So there's two issues over here. I don't know. I can't see that from the picture, by the way. And certainly what I mean by that, I'm looking at that picture, and it just doesn't give me enough detail. And the teacher may think it's being clear, but I'll be honest with you, it's not being clear. So I would have to say, oh, you know what? Let me just specify where that r is going to stop. And I'm going to specify it's stopping when r equals 3. I'm sorry, when theta equals 3. My mistake. So again, it's r equals 3 minus theta. And remember what we're doing. We're just doing area of a sector over here. So let's write it down. So I'm going to put this down for the area. And what's the area going to be? Let's see. I'm starting at 0. I want to point at 0. I would definitely get 3, because if theta is 0, you get the radius of 3. And then I'm going to go to 3. All right. Now, if I did that, I want to point out what happens. Once you hit 3, you're at the origin. Because 3 minus 3 is 0. No radius. All right. So I'm going to say that's what I would say is probably looking at it. I would probably make that assumption looking at the picture. But again, I want to emphasize over here that this does go below the x-axis over there. All right. Let me just back up a little bit and put down this the integrand now. So 1/2 theta, that's d theta in this case over here, r squared. And what's that going to be? 3 minus theta squared. Let me go through the integration. What do we get over here? A equals, I'll pull the half out, 0 to 3. We'll look at the key in a moment. That's going to be 9 minus 6 theta plus theta squared d theta. Going to keep moving through it. We get 1/2. Let's see, that's going to be 9 theta minus, let's see, that's going to be theta squared over 2. And 2 goes in 6 3 times, plus theta cubed over 3. They're kind of nasty numbers, but I can still go through it. Let's see if I can do that. 1/2. 9 times 3 is 27. Minus 3 times 9 is 27. Gee, isn't that convenient? And then 3 cubed over 3 is going to be plus 9. If you evaluate the lower limit with 0, you're just going to get 0. Every single term is 0, and half times 0 is 0. What do you get over there? 9 over 2. All right? Let's look at the key. And I see that over here. Again, I'm going to say the problem's not terribly clear, by the way. For example, if someone said, oh, I think you meant that you're going to pi, and there'd be another little region over here to consider. All right, now granted, I'm exaggerating it there. But again, clarify things that are confusing to you with your teacher. If your teacher's not clear on the problem himself, try to explain yourself why it's not being clear. Thank you.